Hello, I don't record all my repairs. Sometimes I just get something on the desk and I go ahead and I fix it. And I don't think of making a video about it. And that's basically what I've done with this. I've got it on the desk, I've opened it up, I've repaired it reasonably quickly, and then decided I should have actually explained something or tried to make a video out of this, because there's something about this that may be useful to other people. Now then, this is actually a sound processor, and it's the Wersi voice, or Wersi voice, depending on how it's pronounced in Germany, because it's a German company. There we go, it's a Wersi, or Wersi. Now, this is a chorus and vibrato type sound effect, if you like. And what it basically is if you have an organ, and you want to make it sound richer and give it a bit of chorus and things, you would just sit this box on top, plug in there, come back out of it, and this does all its magic tricks and makes it sound fuller, like me. And the other thing is about this was also made as a board that went inside the organ. So if you wanted to build the Wersi organ, you could order kit number 7, kit number 10 and things, and you would get these separate little kits sent to you, or buy it at a later stage. And it had this row of pins along the back here, and this connected up to switches and things on the organ. And that basically is the same as that, but in a separate box. So if you've got an organ that isn't a Wersi, you could sit this on top and plug it in. I think you can even plug in guitars and all sorts of things. But it's a chorus, vibrato, kind of choir type sound that it makes. Now, what I'm trying to get to in this video really is one of the problems that you sometimes come across when you're trying to repair old equipment. Now, this particular machine had some of its chips actually renumbered. And as you might see here, I'm not too sure if I'm zoomed in well enough, but as you see here, these chips say WIC, which I'm guessing is Wersi IC. WIC 5020, there's a WIC 6020 up there as well, and when you go looking online, you can't find out what they are, and I doubt I don't think Wersi is still in production. So finding those chips is going to be a little bit difficult and probably quite expensive, until you find out what they actually are. They're just standard everyday chips that you can sort of buy. This one, the WIC 6020, is actually a 4066 chip, which costs pennies. And if you want a WIC 6020, it would probably cost you pounds instead. But it is actually a 4066. Now then, the expensive ones, the WIC 5020 is actually a Bucket Brigade device, and that's a Philips TDA 1022P, which is a 512 stage Bucket Brigade, and you found a lot of those in guitar pedals, effects units and things, especially, you know, the sort of 70s era. So a 469 is a hex inverter. This one, 14016, is a quad analog switch. There's 4 analog switches in there. That's a dual op amp, and these are quad op amps, and really nice and cheap to buy and replace. These are quad 2-input NAND gates there. So the only expensive parts are these Bucket Brigade devices. So that was reasonably easy to fix, basically, even though I didn't have a clue what I was even looking at. I've got to say thank you to George Brown, who pointed me in the right direction to fix this. And it's nice in a way that repair people can bounce sort of advice off each other. I don't know everything, so I have to sometimes call around and ask for other people's help. And George Brown, thank you, said the problem's there, and he was absolutely correct. Thank you, George. So anyway, let me explain as best as I can what this is doing, because it's quite clever. So what is happening inside this crazy gadget is you've got a few LFOs, low frequency oscillators, and you can see that by the yellow and the green line, which is sort of moving towards the minus 15 volts, and they're kind of nice and gently just moshing up and down at their own speed. And you can change the speeds of all these things. There's a speed control on the front, and there's a slow fast button as well. Now, I made another problem with this, or rather I found another problem with this, which was my problem, and that is there's a little remote control unit here, and the reason for that is you would sort of screw that to the bottom of the organ or something and have a quick access to this. The trouble is, when you plug in this control into the back there, it actually disables these buttons here, and at one point I got it working and I plugged all this in and things, and suddenly nothing was working again, and I kind of sat for ages trying to figure out what I'd done, and I realised I plugged that remote control in, and that disables the front buttons here, which is just one of the daft things that we tend to do sometimes. Anyhow, let me give you a little demonstration on what this actually does. So, on the oscilloscope, the blue line is the audio. Ignore these things. Actually, I might just... no, I'll leave those on. The blue line is the one that we're actually looking for. So, if I just play a sort of a triangle, it's got a little bit of release there, but... yeah, just a basic boring sound, like what a simple organ would provide. However, if I switch on the effect, that's without the effect. Now, switch on the effect, and this should be choir. Yeah, it makes a difference. It sounds a little bit more richer, and you can see what it's doing with the sort of the waveform up there. It's really mashing it up. Now I put in vibrato, and you can kind of hear it sort of phasing around almost. Bit of deep effect. Yeah, deepens it slightly, not too much. Press the fast. Yeah, you have to kind of listen really carefully at what it's doing with that. But there's something really strange about this that I don't understand. And one of the points of this was, instead of using, say, a Leslie speaker and setting up a couple of microphones, you could have a box like this and it would give you the same sort of thing without having to use microphones in setup, etc. But the only problem there is it's only a mono output. It's got two mono inputs that just mix. There's no left and right to this. And then there's a mono output. So I kind of think, well, if I had a Leslie speaker with a stereo pair of microphones, surely that would record and make it a little bit more realistic. But this is trying its best, but I kind of don't understand why it has a mono output, even though the sound that comes out is pretty interesting, pretty impressive. Yeah, okay, not bad. Sounds nice-ish type of thing. So, yeah. So what's happening here is this is affecting, if I use the pink line on the oscilloscope, that one there, you should be able to see the clocking input, which is far too fast. I'll speed this up a little bit. And we will trigger it on source number 4. Bring that in. So you can see how that's sort of coming in and out, sort of vibrating. And that is the clock that's going to the second Bucket Brigade device. So that's making an effect. Now the clock for the first Bucket Brigade device, yeah, sort of same sort of thing. It doesn't go as deep, but let's Let's try the third. See, in the third it's a different pattern. It's doing the same thing, but it's doing it at a different speed. And it's those three different sort of speeds working the signal through the Bucket Brigade devices and then adding all the sounds back together again before the output. That gives it that sort of chorus sound, as if it's got some motion in it. Something's sort of, it's moving, it's alive at last. So effect off. Just plain and boring. Effect on. Yeah, there you go. So I just thought I would kind of try and explain what happens in one of these nice old vintage sort of audio type boards. And that's it basically. 3 Bucket Brigade devices, all at slightly different modulations. You know, the speed, the clocking speeds are slightly different on them all. Send the signal into those 3 and mash them together, mix them together and bring them out the other side, and you suddenly get this nice big lush sound. I think it's a lush sound anyway. The keyboard that I'm using here, I've set it's completely blank. It's just a triangle output, that's all, on one oscillator. That's it. So I'll try to make it as simple as possible on there so you could see the difference of what this device is doing. And yeah, I think it's quite an interesting little circuit. But like I say, if you're diving into repairing things like this, especially from the 70s and 80s, and you come across chips that have very strange numbers on that you can't find online, chances are it's something that you can buy off the shelf. It's a common chip, and they've scrubbed it off because they don't want you to steal their designs. Quite rightly too. Nothing wrong in that. Another thing I thought I'd just show you before I finish is one of the difficult things to find on Google or anything is the actual pinout of the TDA 1022 Bucket Brigade device. So I've kind of written it out for you there. And as you see, there's only actually 8 pins that's in use. 8 of the pins on that 16-pin chip are just not connected. They're not in use at all. So it's just those 8. Clock input 1 and 2, signal input, output. Now there's 2 outputs. One of them's a 513 output, one of them's a 512 output. I don't even understand that myself. There's like I say, there's 512 elements, if you wish, or 512 capacitors, and that's getting moved along with the clock pulses. And 513, I'm not sure, maybe that's a reset. Don't know. If you know about that, please put that down in the comments and tell me what output 513 is on a 512 element Bucket Brigade device, because I cannot find information on that anywhere. There's several types of Bucket Brigade device chips that you can buy, but that's a pretty common one by Philips, and it's such a shame that they just don't make them anymore. You know, there's so many circuits of phasers and flanges and vibratos and choruses and things that you can find in a lot of these nice old magazines, but you can't build them because you can't find that chip, which is a bit of a shame. I see them occasionally on eBay, but they're about 10 UK pounds. Anyhow, I'm sorry that wasn't one of my usual type videos. I just thought I would show you this nice machine while I had it open. This here, by the way, is just a mouse mat, and it's to stop the circuit board shorting on the metal casing, because you have to unscrew it all to get it apart and flip it over, and I just put that mouse mat there to stop it shorting. All of this here is actually live, so always be careful if you're looking into something like this or working on something like this. Always be absolutely sure that you know what is live and what is at mains potential, mains voltage, whatever you wish, and just be careful, but don't be afraid to get in there and have a look yourself. It's amazing what you can fix, even if you don't know nothing about it, and I don't know nothing about that, but I fixed it. Brilliant. Okay, thanks so much for watching, and I'll get on with something pretty soon. All the best. Bye-bye.